Imagine being able to design a brand new medicine from scratch in a matter of days instead of decades. Well, that's not science fiction anymore. Today, we're diving into how AI is becoming this incredible new weapon in our fight against viruses.
But first, let me just ask you this. How long do you think it really takes to get a new drug from a scientist's bright idea all the way to your pharmacy?
The answer, well, it's pretty staggering. We're often talking about a process that takes more than 10 years and costs billions and billions of dollars. It's just a huge, monumental effort. But what if we could flip that script entirely? What if an AI could just look at a virus, figure out its Achilles heel, and then design the perfect molecule to shut it down? Well, believe it or not, that's exactly what's happening right now.
Okay, so first things first. If you want to defeat an enemy, you have to find its weak spot, right? For a virus, that means finding a really critical piece of its internal machinery that we can jam up.
So meet our target. This is the SARS-CoV-2 main protease, or Mpro for short. This little enzyme is absolutely essential for the virus to make copies of itself. So you can think of it like a master lock that the virus has to open to survive. And if you look closer, right there, that colorful little groove on the surface, that is everything. That is the binding pocket, the specific keyhole that we need to block. Its unique 3D shape is the bullseye we're aiming for. So the mission is clear. We need to design a molecule, a tiny key that fits perfectly into this keyhole and jams the whole mechanism. If we can block this lock, the virus literally can't replicate. Game over. All right, so we've got our target. How in the world do you actually design the perfect key for it? Well, this is where the hero of our story steps in, a really powerful type of AI.
The tech is called a Generative Adversarial Network, or GAN, and it's a fascinating idea. You basically have two AIs competing against each other. One is the generator, and it's like an artist, constantly dreaming up brand new molecules. The other is the discriminator, and it acts like an art critic, judging those molecules and telling the artist which ones actually look like real, effective drugs. This constant back and forth forces the artist to get really, really good, really fast. Now, what's so cool is that the researchers used two different AIs for this job. The first one was kind of like a brainstormer. It looked at the general shape of the keyhole and just churned out a massive wave of ideas, over 25,000 potential keys. The second AI was more like a master locksmith. It focused on the tiny, specific details between atoms to craft just about 100 super precise designs.
So now we have tens of thousands of potential keys. Obviously, we can't test all of them in a real lab. That would take forever. So how do we find the needles in the haystack? You guessed it, more computers. The first round of vetting is called molecular docking. You can kind of think of it as a virtual fitting room for molecules. A computer simulates super quickly how well each of the AI's keys fits into the lock. It gives each one a score, which lets us toss out all the bad ideas almost instantly.
And here you go. This is what success looks like. This is a docking pose. You can literally see the new molecule that the AI invented just nestled perfectly right inside that critical keyhole of the Mpro protein. It's a beautiful, perfect match. Now, a good initial fit is awesome, but it's not the whole story. A key doesn't just need to fit, it needs to stay securely in the lock. So the most promising candidates from that first round, they get moved on to a much, much tougher test. This next step is called a molecular dynamics simulation, and it is the ultimate stress test. It's basically like putting the key in the lock and then shaking it like crazy. The simulation shows how all the atoms wiggle and vibrate over time, and it's all designed to answer one crucial question. Does the key stay put?
And these squiggly lines here, they show us the results. They're tracking how much the protein's atoms are moving around. The top line is all over the place. That means it's unstable. But look at the bottom line for FC1, one of the AI's designs. It's almost perfectly flat. That is exactly what you want to see. It means the key is in there so securely, it's actually stabilizing the whole lock.
And the numbers here. Wow, they really tell the story. This binding free energy is just a fancy term for how sticky the key is. A known drug that works against this virus scores around -35. Okay, that's our baseline. But the AI's top design, FC1, it scores a jaw-dropping -70. That's not just a little better, it is twice as sticky. It's a fundamentally stronger key. So, after all of this digital design, this screening, this intense stress testing, the researchers were left with just a handful of champions, the absolute best of the best that the AI had to offer. And here they are,
The winners. 4 molecules, RC1, RC2, RC3, and FC1. These are the ones that passed every single digital test thrown at them. They are the AI's master keys and the most promising candidates to take into a real-world lab.
But this might be the most incredible part of the whole story. The researchers noticed something amazing. All 4 of the winning molecules were built around the exact same chemical core. The AI wasn't just guessing. Working completely from scratch, it independently discovered a foundational master key design that's perfectly tailored to shut this virus down. And the study's conclusion really says it all. The molecules designed from scratch by the AI showed a better, stronger connection to the virus than some already known drugs. I mean, that is a massive proof of concept. And this all leaves us with a really profound question for the future. When the next new virus emerges, could this be our first line of defense? An AI that can design a custom-built medicine in weeks, not years, potentially stopping a pandemic before it can even really start. It's a powerful thing to think about.